Hi, I'm Deepshir Bharadwaj, and here I'm going to present my video assignment on digital image analysis. So topics which I will be covering here will be histogram, limitation of the histogram equalizer, and at the end I will be discussing about the histogram matching. So starting with what is histogram? So the first intuition which comes to our mind is that histogram is a graph which represents all the frequency distributions. That means here we can see all about the observations that how much times it has been came into the picture. So, but how does it relate with the data science world? So, we have been doing a lot of assignments, including machine learning, data science, and everything. So we can directly relate that there's a library in Python, matplotlib, which will be showing us all the intuitions behind it. And with all this histogram equalizer and the histogram matching, this coding part I will be showing here, which I have completed at the end of this video. So starting with what is histogram equalizer? So the histogram equalizer is commonly used to enhance our image. And how does it enhance our image? It enhances our image by flattening our histogram. So at the end, the pixel which was darker in shade will remain darker, and the pixel which was whiter or the brighten will remain the brighter. So but with all this beautiful concept of the histogram equalizer, there lies some limitations. Now let's discuss what are these limitations. So the main limitation is that this method is very indiscriminate, which means like it is not able to distinguish or differentiate between the noise and the image. So if there's any noise, then what it will do, like it is like a dummy algorithm which will like enhance the noise. So which is not like that much feasible. So with apart from this, there's also possibility that the image which we have got here, after passing through this method, it will enhance. No, it's not compulsory that it will enhance further. There might be a possibility that it might degrade. So this is not a very good technique, right? So like going ahead with the uniform equalizer or the uniform histogram, we have the new approach of doing solving this problem. There's a possibility like there's a linear type of equalizer, cubic, quadratic, and so on. But here I will be discussing about the histogram matching. Like what the term matching here means here. So matching here means like if we are given any two objects, we try to match with each other, right? Similarly, here our goal will be given to us that there will be an input image and there will be output image. So I will be trying to match by my input image with the target image, so that my input image will be much close to that output image. How? See, before going to this numerical type, which is not so intuitive, what I will be do, I will be showing you my coding. First this part, and then we will go with the slides. See, apart from all this coding stuff, what I have shown here is that this is the like a result. So first show you the result so that you can understand better that comparison. This is my input image, red one, right? And this is the target image. So at the end, what I want that this image, input image, should look like after the equalizer should be much close to this output image. That will be like it will be more close to my output image. So you can see this output that at the end this my input image has been like more close to be here. See here my uh, the darker pixels have been reduced, and here the output image having the whiter pixels, that is this level at the end level. So you can see that at the output also I am getting only the whiter pixels. Okay, now proceeding here with the algo and the example, how is it is working? See, so my input histogram, there are 8 levels, like which I have taken from the 0 to 7. And with this level, I am having this number of pixels. Like for 0, I am having 790. For the 1, I am having 1023. Similarly, in the output histogram, I don't want anything for the 0, 1, and 2. That way, it's only wanted the brighter shade. So, see, as it is shown here, I only want my output in the wider shade. So, proceeding further, now how I can do? See, what I will be doing, this is a new approach, or this is the most important approach. What I will be doing, I will level up all my gray levels. I will find how many pixels values are there with the same intensity. So for 0, there's 790. So my first approach says that calculate the PDF. Now, how do we calculate a PDF? See, this is the NK that for this point 790, 790 divided by 4096, it will give the 0.96. Similarly, for 1023, it will be 0.25, like 1023 divided by 4096, and so on. I can fill this table easily. Okay. Now coming to the CDF part. For the CDF part, it is like cumulative distribution function, which like normally adds up all this PDF in a like iterative fashion, like 0.19. So it will 0.19, 0.19 plus 0.25, 0.44, 0.19 plus 0.25 plus 0.21, so 0.65, and so on. I can fill this easily. Now coming to this point. Now, what does it say is that the CDF value which I've got here, if I multiply with the number of levels minus 1, that is 8 minus 1, I will get 1.33. Similarly, 0.44 into 7, 3.08, and so on, like 1 into 7, 7. So now what I will do, I will round off this value. Now, 1.33 is more close to 1 than 2. So, here 1, 3.08 to 3, and so on. Now, what I can see here, this zero gray level is being rounded off to 1, and which says like for 1, I am having 790 pixel values. For 3, I am having 1023, and for 5, earlier it was like 2, now it is 5. So it is like a transformation which I have done on my input image. Okay. Now, for the same part which we have done for the input part, let's do with the output image. So here, same all the function like NK, PDS, TDF, everything we can calculate. Oh, right. So now what to do? Now how to map this? This is the very crucial step here. For that, here is the actual meaning of matching comes here. How? See, like we know, like this was the input image, right? But which gray level to map will come with this picture? For example, like for 0, like 0, okay, nothing to map with. If there are like 0 values, then directly it will be 0. Like for 0, 0, 0. Now coming with this 3. Now 3 is saying that it is mapping with the 1. But let's check with which value it has been mapping in the input image. So 3 will be matched with this, and it shows that with the 3 gray level, it is mapping with the number of pixels 790. Similarly, for 4, it is 1023. For 5, it is like 850, and so on. So I can fill these values directly, like 001120, and for the 3 is 790, like you can see here. For 4, 1023 here, and so on. Okay, so now let's look for the scoring part. Like it's not that tough, I think. I coded this from the scratch. See, what I started with the importing all the important libraries. Like for the, I know that there's a lot of computation, so I involved NumPy. And for the plotting, that obviously I started with the matplotlib, right? Okay, so I did, I took all these 8 gray levels into a scale of in a list like this here, and this input histogram with this all the values here, with the output histogram all the values here. Okay, so what I did, I plotted this value directly, and the main important part, like of calculating of the PDF, CDF, and everything, I've calculated here. I will be sharing my this code at the end of the slide too. Okay, so here PDF is there, CDF is there, sum is there, and everything, all the calculation I've done, this all this value which we have found in the table. So similarly, calculation of the SK and for the new NK, final sum, everything I've done here. Now this again PDF, CDF, this is for the like second output image. So like extracting all the values. When I'm trying to graph this, it will be looking like this. So at the like comparison stage, I can show this. Like I was having this a value which were having the pixels towards the left, but I wanted like towards the whiter shade. Then I want to right inside. So what I'll do after applying all the equalization, I can see that my input image has been transformed through this. Okay, thank you.